special segments in triangles. So there are 4 different types of special segments that each make a different kind of a special center. And then they have some properties that we'll talk about too. So we'll go through the different special segments and what centers they make, and then we'll look at how we can apply them. So the first one, okay, this first special segment is called an altitude. Ooh, that's too big. Altitude, yes, an altitude. So an altitude, it's the same thing as the height of a triangle. So if you're just looking at one altitude, the altitude starts at a vertex, and then it goes straight down your triangle and ends perpendicular to the other side. And so in this triangle, there are 3 of them drawn in. So each one starts at a vertex and goes towards the opposite side so that it's perpendicular to that side. So vertex, towards the other side, perpendicular to that side. So all 3 of your altitudes, they cross in the same spot, and that point where they all cross together is called the orthocenter. You will have a word bank and stuff, but you need to know that altitudes make the orthocenters, but you will have a word bank. Orthocenter. So that point right there where they all cross is the orthocenter. Okay, go for it. Yes. Okay, so that's the first one. The most important thing about that, as you need to remember, is that right angles are 90 degrees, and so whenever you have an altitude, you're going to have a right angle and 90 degrees. All right, the next one. These next segments are called medians. So there are 3 medians in this triangle. If you look up here, I'll draw on it for you. So a median also starts at a vertex, and then it goes to the opposite side, but where it connects at the opposite side is the midpoint. And we can tell it's the midpoint because of those congruency marks. It's like these double hashes and these double hashes tell us that what's in between them is the midpoint. So each median goes from vertex to midpoint. Oops, I closed my thing. Where did it go? Oh no. You can't see up there, but I'm having technology issues. There it is. Aha. Vertex to midpoint on the other side. So where all 3 medians meet is called the centroid. Oops, I spelled that wrong. Centroid. And fun fact, you don't have to know this, but it is a cool fun fact. The centroid is the center of gravity of the triangle. So like if you had a triangle, if you knew where the centroid was, that's where it would like balance if you were to balance it on your finger, which is cool. But the centroid does have a special property to it. So do you guys see how each median is split up into like a big piece and then a small piece? So that big piece is double the size of the small piece. So I'm just going to make a little note that says the big piece is 2 times the small piece. So we'll look at another application of this later, but just hypothetically, for example, let's say this small piece on the bottom was 2. How much would this big piece be? 4. There you go. Okay, good. So you guys are getting it. Fantastic. Okay, so that's the first 2 set of vocabulary that we have for today. So the third one. And the third one in this picture, these are all perpendicular bisectors. Perpendicular bisectors. So again, there are 3 in this triangle, 1 for every side. And perpendicular bisectors do 2 things. So first, we'll talk about the bisect part. So if you look at the bottom side of this triangle, this line is bisecting it, which means it goes through the midpoint. So it's cutting it in half. So this point is the midpoint. Again, we can know that because of those 3 little congruency marks on either side. That's what tells us that it's going through the midpoint.
Do the lines mean anything in this situation?
Like which lines? These?
Do we use it for solving? Yeah, the lines that intersect the
Yes, we'll use that for solving. Yes. And then the other piece of the perpendicular bisector is the perpendicular part. So just notice that the perpendicular bisectors are perpendicular. That's why you have those little right angle boxes. It's perpendicular to the side where the midpoint is. Okay, and so when we have 3 of them in a triangle, they all intersect in the same exact place, and we call that place the circumcenter. Which, by the way, I will tell you a fun fact. You do not have to know it, but since I think it's fun, I will share it with you. So if you were to draw a circle around this triangle such that the circle like exactly touched each of the vertices once, which I can't draw that super well, that's called circumscribing a circle around the triangle. That's why it's called the circumcenter, because the circumcenter is like the center of the circumscribed circle. Ooh, ah. So anyways, that's a fun fact. You don't have to know that, but I thought I'd share. That's why it's called the circumcenter. Okay, so anyways, last one. These last ones are angle bisectors. All right, so you can tell it's an angle bisector because each of these lines is cutting an angle in half, and we can tell that because there are little congruency marks on either side of the line that show that, you know, the left half of the angle is equal to the right half of the angle, and so forth and so on. And then all of your angle bisectors, they also intersect at the same exact spot, and we call that spot the incenter. And so your fun fact for that one, it's called the incenter because when you put a circle inside the triangle, which is called an inscribed circle, so that your circle touches each of the sides just once, it's a terrible circle, but you can imagine. The incenter is the center of the inscribed circle. That's why it's called the incenter. So cool, huh? Yeah. Okay, so now let's see how we can apply them, all these things. Yes, so first, we're just going to look at this picture and identify which kind of special segment it is. So, you can look back at the front of your notes, don't say it out loud yet so everybody can think. But go back to the front of your notes and ask yourself which special segment starts at a vertex and is perpendicular to the opposite side. Think in your head. Starts, just in your head. The segment starts at the vertex and is perpendicular to the opposite side. Okay, now what do you think? It's the altitude. Very good. Now, how can we find any missing side of a right triangle? Pythagorean theorem. Ding, ding, ding. Okay, so remember Pythagorean theorem is a squared plus b squared equals c squared. The c is the hypotenuse, which is the 10. So we'll do 6 squared plus x squared equals 10 squared. So we square first before we subtract, so 36 plus x squared equals 100. Subtract 36 from both sides. X squared equals 64. Square root both sides. And x is 8. Okay, questions so far? All right. Okay, next one then. This one says, given the median that's drawn from point L to point O, so that blue line in the middle, in the triangle below, solve for x. So you just have to remember what a median does, and remember, median starts at a midpoint. So medians always start at midpoints, therefore point O is the midpoint. So O is in the middle, which means 4x minus 12 is equal to 3x plus 23. Since O is in the middle, the left half equals the right half. And so now we subtract x's from each side, so minus 3x minus 3x. So on the left I have 1x minus 12 equals 23. And then I'm going to add 12 to both sides to get my x by itself, to get that x is 35. Okay, questions about that one? Okay, tell me if I'm going too fast. You can just shut out. Okay, good so far. All right. Okay, question 3. Given point O is the centroid, what special segment is drawn in the picture below? So look back on the front of your notes. What special segment makes the centroid? The median.
Nice.
There you go. Okay, so these are medians. And there's a lot going on in that picture, so just to point it out, remember that the median starts at a vertex and goes to the midpoint of the other side. So like AE is example of one median.
Is it C and D also?
D is the midpoint also. Yes, so CD is a median, and then BF is also a median. All right, so we're gonna solve for missing pieces. Remember, the rule is the big part of the median is double the small. So if OE is 8, how much is AO?
Times 2, 16.
16. Fabulous. 16. So X is 16.
Because the smaller part of the triangle is always times 2 of the bigger part.
That's good. All right, so going backwards the other way, if the big part, CO, is 14, how much is the smaller part?
28. 28. Divided by 2. Divided by 2. Oh, no, 7.
Divide by 2. 7. 7. Yep. Yep, because the big part equals 2 times the small part.
Wait, how do you know if it's big or if it's...
Excellent. So Y is 12. Very good. You get a happy face for that one. Yay.
Let's go. We're learning.
Yes, this is wonderful.
Okay, lock in. Lock in.
All right. Next one.
Lock in.
We've got to decide first what special segment is in the picture. So don't say anything, but look on the front of your notes. Which special segment is perpendicular and goes through a midpoint? Don't say it out loud. Which one's perpendicular and goes through a midpoint?
It was so good she fell out her seat. She was so proud of me. Yes. She got thrown out.
Okay, what do you guys think? Perpendicular bisector. Yep.
Yeah. Yes. She got it.
Perpendicular bisector. Yes. Yes.
Okay, so 90 equals 3x 90 degrees.
Yep. So 90 equals 3x plus 9 because perpendicular bisectors make right angles, And so it's pointing to the angle. That's what the 3x plus 9 is for. So 90 degrees equals 3x plus 9. So subtract 9 from both sides. We get 81 equals 3 times x. Are you sure?
Yeah.
Okay. Yep, so divide by 3 on both sides. X is 27. Okay, next one. This one I want to have us label it on the picture because it's not labeled already. So if xc is 8y minus 12, so xc is this part, 8y minus 12. And xy, that's the whole thing. Xy is 6y minus 4. And we want to solve for the value of y. So remember, perpendicular bisectors go through the midpoint. So if C in the middle, if C's in the middle, how many XC segments fit into the whole thing? 2, right? 1 and 2. So our formula is going to be 8y minus 12 plus 8y minus 12 is equal to the whole thing, 6y minus 4.
So this is a two-step formula.
Wait. So you know that they're equal, like that, so both sides are equal because it's a bisector?
Yes, and bisectors go through the middle.
Okay.
So now we're just going to solve. So I'm going to first just combine my like terms on the left side. So on the left side, 8y and 8y are like terms, so they combine to 16y. And then the minus 12 and the minus 12 are like terms, they combine to minus 24. And then I'll add 24 to both sides and subtract 6y from both sides. To get that 10y equals 20. So we can divide by 10 on both sides and get that y equals 2. All right, questions about that one? Okay, I think this is our last one. Oh no, second to last one. Okay, so in this one, what special segment is shown below? So look on the front of your notes, which one gives you two little angle pieces that are the same?
Angle bisector.
Angle bisector, excellent. Angle bisector. So angle bisectors split angles in half, which means that the first part of the angle is the same as the second part. So that means those little angle pieces are equal. So 2x plus 2 equals 6x minus 26. And then we just solve for x, so plus 26 on both sides. Minus 2x on both sides. Divide by 4 on both sides, and x equals 7. Okay, now last one. Okay, so if SU is an altitude, solve for x, which means we have to remember what an altitude has that's special about it. So look on the front of your notes and look at what is special about the altitude.
They all exist at a different point.
Next to the vertex.
Starts at the vertex, and then it's what to the opposite side?
Perpendicular.
Perpendicular. That's the special thing about the altitude. So if it's perpendicular to the other side, that means it's making right angles, and we know right angles are 90 degrees. So if that little angle is 5x, and we know it's 90 degrees, then 5x equals 90. So we can divide by 5 on both sides, and x is 18.